Hello everyone, my name is Hariprasath. We are going to see about Dbtt industrial examples. First, we need to understand what is Dbtt. Dbtt means ductile to brittle transition temperature. Basically, metals fracture at two types. One is brittle fracture, another one is ductile fracture. So, metal possesses brittle and ductile fracture. Brittle fracture, the metal fails or fracture at sudden fractures take place, whereas in the whereas in the ductile fracture, first the metal start nicking. First the metal start nicking, moves plastic deformation, create necking, and then it gets failure. But in Dbtt, in ductile and brittle, one metal possesses only one failure, one ductile or whether ductile fracture or brittle fracture. But in the Dbtt, same metal possesses ductile fracture and also brittle fracture. Above the ductile to brittle transition temperature, it fails as a ductile fracture. If the stress is applied, it deforms plastically and then attain failure. Below that transition temperature, the metal breaks suddenly, failure suddenly. That is known as brittle fracture. This occurs only in BCC crystal structures, not in FCC crystal structures, because in BCC it has limited number of independent slips. It only occurs in the BCC crystals, not in FCC crystals. Due to this phenomena, more machines and many vehicles damage and everything get damaged. Let us see what are the industrial examples that comes under in Dbtt concept. Many things occurs under Dbtt. Now we see about 5 examples. For shipbuilding, pipelines, pressure vessels, cryogenic breakdowns, and some others. First example, shipbuildings. Everyone knows about Titanic. Titanic is failure because of this Dbtt. Engineers on that time says the Titanic never sink in the water, but due to the very low temperature in the surrounding, the Titanic metals undergoes Dbtt, ductile to brittle transition, that causes the failure in the Titanic. So in the shipbuilding, we need to oil and gas pipelines are built underground throughout the world. The construction of oil and gas pipelines in the cold region may cause Dbtt, ductile fractures in the low stresses. So we need to ensure the metal can withstand the design ensures the operating temperature above the Dbtt. Next example we have to see, we are going to see about is pressure vessels. Pressure vessels means it stores something. It shows something inside the vessel's pressure or in high pressure. We need to build a ship with the correct metals, and we need to take precautions, because commercial ships and domestic ships travel all around the world. It also covers high temperature and low temperature like Arctic regions. So we need to construct a ship. Inside the pressure vessels, the pressure changes. Pressures are maintained in high pressure with compared to surrounding or atmospheric pressure. At lower temperature, it possesses Dbtt effect. And we are going to another example: bridges. Famous bridges like Silver Bridge collapse, Duplessis bridges, they are all collapsed. They are built in the cold region. The steel used in the bridge can become brittle in the cold climates. So engineers builds the bridge with suitable metals to withstand sudden failure risks. Due to weather changes, it may be happens. Due to change in cold climate, it may be happens. Cryogenic storage tanks. Liquid nitrogen, liquid oxygen, liquid hydrogen and LNG are stored inside these cryogenic storage tanks. The temperature of these liquids may goes in minus 196 to minus 220 degrees. To withstand these low temperature, steel becomes brittle below this Dbtt temperature, so it may cause sudden fracture. Now we are going to see about preventions, how to prevent the ductile failure, brittle to ductile failure. Material selection is the one of the prevention method. Use low carbon steels and low sulfur steels. It can withstand at the lower temperatures and does not possess the brittle fracture. Austenitic steels remain ductile at low temperatures. Metals like low carbon steels and sulfur steel and austenitic steels remains ductile at low temperature, whereas other steels other steels like perlitic and ferritic steels, they contain BCC structure. BCC is crystalline structure. It possesses brittle to ductile transition effect at a low temperature. But these metals do not failure at like brittle or sudden failure. Alloying elements. Alloying element nickel, manganese, molybdenum lowers the Dbtt temperatures. It will cause a stacking fault. Due to this stacking fault, screw edge extraction takes place. Screw edge extraction takes place. The metal, when stress is applied, the metal deform plastically. It possesses ductility. It reduces the brittle nature of the metal. So we need to add alloying element like nickel, manganese, molybdenum. It makes the microstructure fine grains. It lowers the Dbtt transition temperature. So we need to add alloying element to avoid brittle fracture. And next we see about heat treatment. Heat treatment like grain refining, tempering. It reduces the grain stresses. It and heat treatment like annealing form a coarse grain. If the grain size is larger, plastic deformation takes place. Plastic deformation takes place means the material or metal behaves ductile. So we don't need fine grains, because fine grains does not causes plastic deformation. If plastic deformation doesn't takes place, the metal does not failure ductility or ductility never takes places. So retreatment like annealing, tempering and controlled cooling reduces internal stress, and grain refinement improves ductility. The annealing, tempering, grain refinement reduces the internal stresses inside the metal. And next we need to test the metal like surface impact test and sharpening factors ensure the operating temperature above the Dbtt. If the surrounding is like example minus 50 degrees Celsius, the ductile to brittle nature of the metal must be above that temperature to avoid the brittle fractures. We are seen about 5 examples like this TBDT have effects on the shipbuilding, oil and gas pipelines, and pressure vessels, bridges and bridge frameworks, cryogenic storage tanks. Due to the ductile to brittle transition, these operations metals are fracture at ductilely, but due to this we need this prevention technique like material selection, alloying elements, and heat treatment. By means of these, the material or metal can be saved from the brittle failure. We are saying about what is Dbtt and at what temperature it's safe. Safe means deform plastically or ductile fracture takes place, and at below that temperature it behaves like a brittle material, and fracture and sudden fracture takes place. Prevention method like materials using alloying and heat treatment. I missed about designs. Sharp edged design makes the metal brittle, so we need to curve design in the metal. It reduces the stress and metal behave like a ductile. Dbtt influence in shipbuilding or cryogenic storage tanks and pressure vessels. Thank you.